Hey, this is the practice homework for naming transition metals and writing formulas for transition metals. These are a little tricky. Transition metals, you'll find them in the middle of your periodic table. Okay, mine's colored green right here. But you'll find them in the middle of your periodic table, and they don't have a standard single oxidation number. So what you have to do is you have to find their oxidation number. They're variable valence metals, which means they can have varying valence numbers. So first thing we need to do, kind of step 0 for all of this, is to look at the metal in each of your compounds. Okay? Ask yourself, is it a transition metal? Well, all of these are because they're on the transition metal worksheet. But if you aren't sure, step 0 is you have to make sure that it's a transition metal first, because there's a lot more work involved when you have to write formulas and name compounds that have transition metals in them. If we don't have to do all that work, that's even better. So first thing to do, step 0, check the metal and see if it's a transition metal. Mercury is a transition metal, and so what we need to do to find the oxidation number of mercury is we uncrisscross. Remember, we can crisscross and make subscripts. Well, we can uncrisscross to find their oxidation numbers. So since there's no number there, it's assumed that it's a 1. So you draw back there and you put a -1 there. You take the 2 that's next to fluorine and you put it up there above mercury. Then you check the oxidation number on that nonmetal. Fluorine always has an oxidation number of -1. And if the nonmetal is correct, that means the metal's correct. So since fluorine's always a -1, then bingo, mercury's oxidation number is 2. So we have to name this thing mercury 2, and put that in parentheses, 2 fluoride. Okay, it's a binary compound, so we get that IDE at the end for fluorine. Okay, let's try the next one. So there's no oxidation number, or I'm sorry, there's no subscript there. So when there's no subscript, you assume that it's a 1. So if I uncrisscross that, that would be a -1 there and a +1 there. Well, then I look at the nonmetal. Does oxygen always have an oxidation number of -1? No, it doesn't. So how do I make that a -2? It's always -2. So what would I need to do to make that a -2? Well, I need to multiply it by 2 to make that a -2. Well, whatever I have to do to the nonmetal, I have to do it to the metal too. So I'm going to multiply that by 2. So iron's oxidation number is going to be +2. So this is going to be iron 2 oxide. Okay, let's try the next one. Backwards or uncrisscross. That means a -1 there for iodine and a +2 there for tin. Well, does iodine have a -1 oxidation number? Well, yeah, it's in the halogens. It is a -1. So that means that that +2 on tin is correct. So we name this tin 2 iodide. Okay, last one on our naming, writing names. Okay, uncrisscross again. Put the +4 up here above lead. Put the -1 here above iodine. There's nothing there next to lead, so we assume it's a 1. So does iodine always have a -1 oxidation number? Yes, it does. So that means lead is correct. So this is going to be lead 4 iodide. Okay, so let's do some formula writing. We're going to take the names and make them into the formulas. Well, mercury is going to be Hg, and chlorine is Cl. We need to find the oxidation numbers. Well, the easiest way to find the oxidation number for these transition metals is to look at the Roman numeral. That 2 means that mercury has a +2 oxidation number. Chlorine is in group 7, and for lack of another rule, we say it's -1. So we're going to crisscross these and leave the charges behind. So I'm going to make that over there 2 and take that 1 and put it right there. So the formula for mercury 2 chloride would be HgCl2. All right, for silver chloride, silver is Ag and chlorine again Cl. Silver is an exception to that transition metal rule. Silver is in the transition metals, but silver always has a +1 oxidation number. There was that those 3 elements that always had were the exception in the transition metals. Silver is always +1, zinc is +2, and cadmium's +3. And it's right there in that little triangle area. So since silver always has the same oxidation number, +1, it does not get a Roman numeral. So that's why there's not one there. So this formula, see silver +1, chlorine -1, crisscross applesauce, and you get HeCl. All right, not always that easy, and that could trick you too because there's no number there, there's no Roman numeral there. You just have to remember that it's an exception. All right, tin-4 fluoride. 4 is the oxidation number for tin, so I'm going to go ahead and put SN and put the +4 over here. Fluorine is F, and it has an oxidation number of -1 all the time. So I would crisscross these and use them as subscripts, and I would have SnF4 for tin-4 fluoride. Remember, crisscross them. Cobalt is CO, and what is its oxidation number? It's a 3, +3. Iodide is I, and it's got a -1 oxidation number. Crisscross them, use them as subscripts, and the formula is COI3. So yeah, good luck with the transition metals naming.